Today we're going to go over radical, rational, and absolute value equations. While these are only worth 5 points on your average SAT, the concepts that you're going to learn here apply to a lot of other concepts as well, and so these ones are a must-know. Our approach is going to be to identify radical, rational, and absolute value equation questions. We're going to break down the question, we're going to build a formula to solve them, and then we're going to solve a practice question together. So how do you identify these? Well, they'll either give you a radical, a rational, or an absolute value equation. Now, radicals are going to be identified because they're going to have the square root, and they could look something like root 3x plus 5 equals 7. So that would be a radical equation. Rational equations are just going to be equations where we find x's in the denominator or other variables in the denominator of our equation. And so this one we can see we have those, and so that is going to be a rational equation. And then lastly, we have absolute value equations. And absolute value equations are going to be marked by these absolute value bars. And these bars are going to mean that whatever is inside of them, if it's negative, becomes positive, and if it's positive, stays positive. And how you're going to solve these absolute value ones is going to be to set two equations. So our first one is going to look exactly like our equations written without the absolute value bars. And then the other equation is going to look the same inside the absolute value bars, but we're going to transfer a negative to whatever's on the other side of the equation. So here's our formula for these. We're going to identify it as a radical, a rational, or an absolute value equation. We're going to solve the equation, and then we're going to apply our answer to the question. So here's an example. It asks us, what is the smallest solution to the given equation? So I think this is a radical because I'm seeing these absolute value bars. So that's telling me radical. Now, to solve this equation, I'm going to have to get rid of these radical or the square root signs. And so I'm going to square both sides. So let's do that over here. Okay, so we can square both sides, which is going to give us x minus 4 squared equals 3x plus 42. Okay, and I'm going to FOIL out this left side. So x minus 4 squared is going to give me x squared minus 8 squared plus 16 equals 3x plus 42. And lastly, we're going to isolate our terms. So we have x squared minus 11x minus 26 equals 0. So now we're looking for two terms that add to negative 11 and multiply to negative 26. And what I think this is x minus 13 times x plus 2 equals 0. And this is going to give us roots of x equals 13 and negative 2. So here's all the math to get us our correct answer on this one, but it's actually asking for the smallest solution. Be careful to pay attention to what these ones ask for. And so between 13 and negative 2, x equals negative 2 is going to be our answer. Now, hopefully all this math made sense, but let's look in Desmos because I think there's a much quicker way to finish this problem. So now that we're in Desmos, I'm going to write each side of our equation as their own equation. So for the top one, square root of x minus 4, and then that one's going to be squared. Then for our second equation, it's going to be square root of 3x plus 42. Okay, now we have them both graphed. And I'm going to zoom out a little bit so I can see both of our intersections. And let's look at where our lines intersect. And I can do this by just clicking on the points that look like they intersect, negative 2, 6, and 13, 9. So in about 30 seconds, I did all of that math work here in Desmos. It got us our two roots of negative 2 and 13. And for this specific problem, I know we're looking for x's because the problem only gives us x's. So between negative 2 and 13, negative 2 is going to be the smaller root, which is exactly what we found here but in Desmos it was much quicker and much easier. So definitely use Desmos on these, whether it's to do the problem itself or just to check your work like we did, but it's definitely useful, so make sure you're using it in this concept. -2 is our answer, and good luck on these.